currently an engineer at the Space Johnson Space Center in Houston, Texas, where he has been since 1996. Prior to that, Russ held engineering roles at the Kennedy Space Center and at the United States Air Force, and was also did some time with the UGA Extension Service. He holds a bachelor's and master's degree in agricultural engineering from the University of Georgia. While at UGA, Russ was a member of the Alpha Gamma Rho fraternity and the American Society of Agricultural Engineers. He attended Young Harris College briefly before coming to UGA and is a graduate of the Atlanta public school system where he grew up. Russ also is proud to witness some of the greatest UGA athletic accomplishments, like seeing the UGA football national championship and UGA basketball make it to the Final Four. Many of y'all may not realize basketball has some history here. Russ and his wife, Kristen, have been married since 1999, and she works for NASA on the International Space Station program. They have one daughter, Elizabeth, who's now a freshman at George Mason University in Virginia. And I've had the pleasure of visiting with Russ in Houston last year, and I'm grateful that alumni like him remain engaged with UGA engineering and our students. And I'm delighted he's given us some of his time tonight. So with that, Russ, the floor is yours, and thank you again for being here.
Thank you, Jan. Appreciate it. And thanks for everybody that turned out. And what I'm going to talk about today is how an ag engineer winds up working at the space program. So just a little more background. I'm old enough that, I predate the College of Engineering. So I actually graduated from the College of Agriculture. So I'm really pleased, proud. I mean, I love the fact that there's a College of Engineering at Georgia now. And I really love seeing all the accomplishments that y'all are doing. This is great. I watched the launch last week. It was fabulous. I get just as excited as if I was a student there today. So I really love seeing that. So anyway, with that, I'll let me figure out how to share my screen, get the pitch going. Okay. Everybody see that all right?
I'm not sure that it is sharing. Try it again, maybe.
All right, let me share it. Make sure it again. Share.
There it is.
There we go. Got it. Thank you. Got to keep me honest, Trevor.
Always.
Okay. So, I'm going to say this is my journey from Driftmeyer to the space program. And I graduated back in the dark ages, just after the Earth cooled in 1983 and 87, like Jan said. So, people always ask me, how does somebody go from, working with irrigation systems and greenhouses and tobacco barns and then the Air Force, how do you go from there working in the space program? And, I had a few different inspirations. I'm a child of Apollo. So it means that, when I was 9 years old, Christmas Eve at my grandmother's house in Livonia, we watched Apollo 8 orbit the moon and on live TV. So I can still remember seeing that. And then, the next year I saw Neil Armstrong walk on the moon and saw the launches. And then in high school, I saw, Viking land on Mars. And in the late 70s, right as I started in college, I watched the Space Shuttle Enterprise, which was a test vehicle, land at the Atlanta Hartsfield Airport. And then when I was in school, the space shuttle was just starting to fly, and they were talking about building this thing called Space Station Freedom. And so as an ag engineer, I started thinking about it. It's like, well, that's kind of interesting. I wonder if they're going to live in space for a long period of time, they'll need food. So that was always in the back of my mind, but it just seemed like a crazy idea. So, after graduation, I worked, as Jan mentioned, I worked for the Cooperative Extension Service. And part of the College of Agriculture, there's three tiers or three pillars. There's the teaching, there's research like you do in engineering, and then there's a third leg called extension, which is to extend that learning out to the general public. So it's typically tied to agriculture, which is a large industry in Georgia. And so that's what I worked on. We did energy audits for tobacco barns and greenhouses. And we would look at how you would heat or cool these structures, how the growers could use different materials, different methods for heating or cooling. And the idea was to save energy, save money. Later, also worked with the engineering, the research program arm of the engineering service for the university. And actually, even though this says College of Engineering, it was the College of Agriculture Research back then, engineering. And that I worked with irrigation systems. And you can see there on the bottom right, some of the high technology that we used. That's an Apple II computer, which we had in a strap down in the back of a van, and we would drive that to a farmer's farm and take data from his irrigation system and would spit out a little paper tape and tell them how good their irrigation system was working or what they could do to improve it. And it was like we came from Mars. They thought that was just the highest technology there was. But, it still wasn't getting me any closer to working with the space program. I really enjoyed doing that work. I think it's important work. But, in the back of my mind, I still wanted to figure out, well, how could I get to the space program? And when I was in grad school, I was presenting a paper at the American Society of Agricultural Engineers meeting, and excuse me. And at the meeting, there was another ag engineer there that was presenting a paper about a small plant growth unit that would fly in space. And, it was like the eureka moment. It's like, wow, these people exist. There really is another ag engineer that's out there working in the space program. And so, I made contact with that guy, found out who he was working with at the Kennedy Space Center, who was also an agricultural engineer. And, from that point on, I knew where I wanted to go. I knew that it existed, what I wanted to do existed, and that I could possibly get there one day. So, of course, they weren't hiring right then. So I continued to, continue through grad school, finish grad school. And I thought, well, I could go work. At the time, there were a lot of engineers that were working at Warner Robins Air Force Base. We were actually classified as electronics engineers because we had a great background in electronics and electrical systems. Our department head, Dr. Robert Brown, was an electrical engineer by trade. And so he made sure we had a good understanding of that. And so we were actually classified as electronics engineers by the Air Force. So I went and worked there, and it was interesting. Worked on F-15 fighters, cargo planes, different gunships, and it was all aimed at trying to increase the reliability of the electronic components. I got some really good training, graduate level courses at the Air Force Institute of Technology up in Wright-Patt, and reliability, probability, some detailed statistics work. That was, good background, good information. And, I don't know if you offer anything like reliability engineering in any of your classes, but if you have an opportunity to take classes like that, I highly recommend it because it's a good background for any types of engineering because it helps you understand how things fail and how to make them better. But, I still wasn't getting close to, still wasn't getting me quite down to the Kennedy Space Center. I kept bugging them, and finally, one day I got a call from them, and they said, "Hey, we've opened up a job. Are you ready you want to come down here to work?" So yeah, baby, I was ready to go. So I took off down to Kennedy Space Center to work on something called CELS, or Controlled Ecological Life Support Systems. So what that mouthful means, it's a large combined life support system that basically recycles as much as you can, and it's used for long duration space missions. So you have to stay long enough and you need to go far enough away. So it's not like this would not be for a space station. This would be for a lunar base or a Mars base or something, out there. And so this was like something I would been dreaming to do, and it fit right into my agricultural engineering wheelhouse. I was able to use the controls experiences that I'd gained by looking at how greenhouses were controlled and heated and cooled, the controls used for irrigation systems, understanding how the plants reacted to their environment, the different things that they needed, and working with other engineers, chemical engineers, mechanical engineer, well, not many mechanical, but some computer engineers, some chemical engineers, to combine some of the other processes. We were building, testing a large system at the Kennedy Space Center. These are some cartoons that were developed back in the 80s that kind of showed, what the processes could be in the future. And the little cartoon in the bottom left kind of gives a rough idea of how things are, how the plants produce oxygen. Human consumes the oxygen, produces CO2, which the plants use. You've got gray water through humidity in the air or through waste products. The plants can process some of that. You can also use other types of microbial reactors or other physical processes to try to recover some of those resources and start recycling those things. And the goal being that you recycle all the resources. We were obviously never able to get there. That's a really hard thing to do, but that's our goal was to try to shorten those cycles as much as we could and reuse as much as we can. Excuse me. So what I like to tell people, we actually even recycled the chamber that we built that we used this system in. The picture on the left is probably the best picture that we could get of it when I was there, because we just kind of kept building up support structure all around it. But that's an old pressure chamber that was used during the Gemini days back in the early 60s. They would put Gemini space capsules in there and bring them to vacuum, and they would test, make sure the chamber, the space vehicles worked all right. It was just sitting there unused. And so NASA took it, welded a floor in the middle to cut it into upper and lower chamber. And then we added air handlers around it and turned it into a plant growth chamber. And this is a look inside, and you can see we were growing food crops. We would grow lettuce on the left. On the right is wheat. We grew potatoes and things like that. Typically the things that humans would eat that you could turn into a variety of different products. We would use the waste from the plants and try to break that down and to get the nutrients back out of that. We would feed that to different reactors. Let me see that. Well, this is some of the control systems we use. We use programmable logic controllers, which I don't think anybody uses anymore, but these were old industrial type of controllers. We were kind of going from that towards more PCs and just microprocessor based controls while I was there. But we would use different reactors. This is a microbial reactor to use microbes trying to break down the things. We also, I don't think I have a picture of it, but we would also use fish to eat some of the plant waste and things like that, and try to turn that into, another food source and use them to break down the inedible plant waste into something that the next crop of plants could use. So we did a variety of tests. We would grow wheat and potatoes and just continuously recycle it. We would actually run tests for up to 400 days. So the other thing we would study, this was early in the days of LED lighting. And so there weren't the white LEDs like you would see today. It was red and green. And the new thing back then was blue LEDs. Those were, had just come on to the market. And so you could combine the red, green, and blue to get a white light and try to give the plants the frequencies of light that they needed. Because lighting is a huge energy it takes a lot of energy. And so LED lights are a little more efficient. And so we were trying to figure out how to use that. So we would do research and different things like that as well. So I got mentioned, we ran this thing continuously. We would do recycled tests for up to 400 days. We could, produce, obviously the environment inside is ideal. So it's not like outside, where you have cloudy days and wet days and cold days and hot days. We would give the plants exactly what they needed. And so we would get record crop yields. But still, this was just a test bed. And this was just to prove the concept that you could do this, which I think we did. But, our system had about 20 square meters, so we could produce enough oxygen and remove CO2 from about one person. But for the food, you'd need about 50 square meters to produce the calories that the person needed. And we weren't able to do that, but that we were limited by the facility that we had. So here's a picture of the team. I'm back in the back left with the red hair mustache. I used to have red hair back in the day. So, but from there, I got a call one day, and they asked if I knew of any ag engineer that was interested in working at Johnson Space Center, because they were wanting to combine this with human testing, not testing on humans, but have humans live in the chambers. And it took me about 10 minutes to realize they were asking if I wanted to move to Houston. So I decided to pack up, move to Houston, and that was in '96, and I've been in Houston ever since then. And that was what we were doing. It was part of the larger advanced life support testing where we had humans in the loop. We would take a variety of technologies and combine them in these large test beds. They had a couple of different programs: the Lunar Mars Life Support Test Program, and then the Bioregenerative Life Support Test Complex, and then below some of the other programs that I worked on there. This is just a rough block diagram again that shows some of the concepts of how you can have humans and plants and recycle different things. You've got the food in the top right, and how the food feeds in, and the nutrients you get from the different waste products, the thermal control to keep everything cool or warm as needed, the nutrient solutions for the plants. There's a salad machine that's, so you can have fresh salads right away. Waste processing for the people. You got a crew cabin with, oxygen and CO2 removal and trace contaminant control removal and filters and so on. Then you've got water processing in the bottom left. And so we would try to tie all these different subsystems together to have a closed recycled system. And again, the goal of this is at this scale would be for a long duration mission somewhere far enough away. You have to go go far enough away, and you have to stay long enough for these things to start paying off. So a Mars base or a moon base is where you really start to see these things paying off. A space station, or maybe even a moon, you're only 3 days away from the moon. You're only 90 minutes away from the space station. And so I tell people that's like camping across the street from a grocery store. You're not gonna start planning everything if you can just walk across the street and get your supplies. But if you go out in the middle of the desert or something, or out in the middle of nowhere, then you're going to start trying to become more self-sufficient. And that's the idea behind these concepts. So the Lunar Mars Life Support Test Project, I mentioned that. That's a chamber on the left-hand side. That was another large vacuum chamber. This was actually 20 feet in diameter. This is a lot larger than the one that we had at the Kennedy Space Center. This one had 3 floors on it, and we would have equipment inside and out, and then we would run tests with 4 people living inside there. And we had a variety of tests, and here's just some of the technologies that we used. And we also would test out things that were going to be used on the space station. This was in the days just before the space station was finished. And we were looking at testing out some of the technologies that might be used on space station as well. So there's varying degrees of recycling that we could use. But this Lunar Mars Life Support Test Project, we had a smaller chamber where we had one person living in there for 15 days, and they used a week to produce oxygen. And, you know, I was kind of underwhelmed by that. You know, I thought everybody knew that plants produced oxygen and used CO2, but anyway, I guess we had to prove it to ourselves. I don't know. But then we started getting into the longer tests, the 30-day test, the 60-day test, and a 91-day test. And it's 91 days because we found out in the middle of it that there actually had been a 90-day test somewhere else back in the 60s. And so we decided to stay an extra day so we could break the record at that time. So it was a 91-day test. You know, we tested a variety of equipment, and this was also beginning to test human subjects in isolation and things like that. And so, you know, this is before our space station. We'd had Skylab, but this was before we were going to have ISS, and so we were wanting to understand how people really started to deal with long duration missions. That a lot of that was going to feed into a project called the Bioplex, which was going to be consisted of 5 of these large chambers connected together to a central tunnel, and we were going to have people living in there for 500 days. We started outfitting it. Here's some of the pictures of the first chamber moving into the facility. You can see some of the equipment moving in. Here's some views inside, and we started outfitting it, and then unfortunately it got canceled. So welcome to the government contracting world. That's what happens sometimes. So from that got canceled, and I went off and worked flight projects. So from there, I left and worked on the crew healthcare system. It's also called CHEX, pronounced CHEX. And that was the equipment that's still used today on the International Space Station to support human health and fitness. It's broken down to the environmental health monitoring, the countermeasure system, which is like the exercise systems, health maintenance system. And there's a medical kit for health maintenance, the Colbert, which is actually the treadmill. And I don't know what Colbert stands for, but they named it after Stephen Colbert because Sonny Williams, astronaut, who's actually my neighbor down the street, she was on the Colbert show, and he wanted something named after him. So they somehow tortured the name of the treadmill and made it fit Colbert. So that's the name of that. And the resistance exercise device, and then a microbial water analysis kit. So those are just some examples. On the left, you can see the resistance exercise devices. Ed Liu is doing weightlifting. The 2 canisters on each side have resistive pistons inside that allows him to lift weights. And then in the center and on the right is Sonny Williams, and she's on the treadmill, the Colbert, but she actually virtually ran the London Marathon. The Boston Marathon, excuse me, because she's from Boston. She ran the Boston Marathon on the treadmill while she was up in the space station. So she gave it a good workout. I don't think the engineers that actually took care of that really appreciated it. They were worried it was going to break, but actually it held up fine. So there's the water analysis kit, and then the medical kit is exactly what you'd expect. It's a bag full of drugs and vitamins and different medical supplies. Those are the things that we still send up today for the astronauts. And from there, excuse me, I had an offer to go work in commercial aerospace, and I actually left and went to a company called Bigelow Aerospace. They're still around, privately owned and financed, and they were building inflatable space modules based on a NASA technology called Transhab, where you'd send up a structure deflated so it would fit on a smaller rocket, and then once in orbit you would inflate it so you got a larger volume, usable volume. So he took that concept from NASA, built on it, and was looking to launch inflatable modules. and commercialize it. To my knowledge, I don't think he's commercialized it, although he does have a module that's attached to the space station that is a long duration test module, and it provides some more volume for the space station. Excuse me. So here's some pictures of some of the things that on the top right are ground test facilities, some of the concepts that he had at the time that, those are solid structures, but it same size and volume. On the left is a picture of the system, and you can see on the in the middle there's a cartoon of a structure that it would blow up. Shows it compared to an ISS module at that time. So you get a lot more volume, workable volume in it. Also from there, I went to another company called Paragon that provided life support hardware, environmental control and life support. I also provided thermal design to a variety of other commercial companies, and they're still doing the same. They work with the commercial crew program, providing life support and thermal control technologies to those variety of companies. When I was there, NASA was developing a new spacesuit, the Constellation spacesuit system, and I worked on that to help develop the concepts of a new spacesuit. There's a picture of it. And on the right-hand side is a guy standing there in his liquid cooling garment. So there's a variety of advanced exploration EVA suits that NASA's developing, and this was an earlier development that's now morphed into the current EVA suits. And then from there, back in around 2010, 11, Space Shuttle was coming to a halt. They were laying off a lot of people. There was a lot of change in the industry. A lot of people were leaving the industry, and I had an opportunity to go work at air quality testing company here in Houston with the oil and gas. A lot of people, oil and gas is obviously a huge business here in Houston, and there's a lot of engineers that go back and forth between aerospace and oil and gas. I thought, well, maybe this is my chance to go see what that's like. So I went and did that for a couple of years and found out that that really wasn't for me. So after about a year and a half, listening to my wife, who still worked at NASA, and she would talk about what she was doing at work, and I realized I still missed that, and I wanted to get back into it. So I came back into it, and I started working for SAIC in the safety and mission assurance. And that's where I've been since 2013, and I've really enjoyed it. I've worked on a variety of different programs. I lead a team of systems engineers that cover a variety of different spacecraft systems. So, my specialty through the years has become life support systems, because that's where I started out in advanced life support with plants, and that evolved into more traditional life support systems that are used on the space station or in space vehicles, smaller space vehicles, and thermal control systems. But I work with other engineers that cover things like propulsion and guidance and navigation control and avionics and mechanisms and structures and flight software and all those different systems that come together to make up a functioning spacecraft. So our team works on the different programs, and we work with NASA to make sure that the spacecraft are designed and operated in a safe manner. So we'll look at the designs, work with the engineering groups that are designing them, make sure that we figured out how these things can fail. Have we covered all the failures? Have we identified all the hazards? How do we mitigate these hazards and try to make the things safe for humans? So that, everything we do, we're dealing with human space flight, and our goal is to make sure that the humans are safe. So some of the projects that we worked on is the Orion multi-purpose crew vehicle, the Orion MPCV, the commercial crew program, and currently the human lander system, which is a new program to take the first woman and the next man back to the moon. And and then here's my commercial. Y'all are all aerospace students. You probably recognize this, but I have people in the general public and say, well, what's NASA doing? They're not doing a whole lot. You may not see it in the news, but NASA's currently involved in developing 4 human-rated spacecraft at the same time. You've got Orion, you've got the 2 commercial crew programs, and you've got the human lander system. That's more than any country has ever done ever at one time. So there's a lot going on, but you may not hear about it. You may not see it. It's not the 400,000 people of Apollo and 2% of the national budget spending, but there's a lot of activity going on, and it's really exciting time to be working here. So y'all are right at you're right at the perfect spot and the perfect time to get in on these things. And I'm glad I've got to see it here towards the end of my career. So just to mention some of the programs that we worked about, I'd mentioned Orion. That's part of a larger program called Artemis. And for any of you fans of mythology, Artemis was the sister of Apollo. So that's where they came up with the name. Don't read too much, because I read something else that said Artemis also killed her brother. So hopefully this doesn't kill Apollo, but anyway. But part of the Apollo Artemis program, you've got Orion, which we work on. There's Gateway, which is basically a space station in a Lagrange point near the moon. Excuse me. That's an outpost just planned to be used for exploration. And then you've got the human lander system. In my group, we work on the Orion and we work on the human lander system. We're not working Gateway. There's another group working Gateway. Personally, I work on the human lander system for the thermal control and ecosystems. Let's see. There's a picture of what the Gateway would look like orbiting the moon with you've got Orion attached to it, and you've got the different elements that make up the Gateway outpost. This is the Orion vehicle that's being built by Lockheed Martin. It's an exploration vehicle for missions up to 21 days in length. Excuse me. It can carry 2 to 6 people. It's got 9 cubic meters of volume. There's going to be an uncrewed launch next fall. Like I said, it's being built by Lockheed Martin. Also, the service module is being built, provided by ESA, the European Space Agency. And this is a traditional government procurement, meaning that Lockheed Martin and ESA, Lockheed Martin will integrate this, build it all, and then they will deliver it to NASA, just like the space shuttle was delivered to NASA, or the Apollo spacecraft. Those were delivered to NASA and operated by NASA. So this is a traditional government procurement. And I point that out because the next program, the Human Lander System, is a commercial procurement, meaning that NASA's purchasing a service. They're not going to own the vehicle. And this is was just down selected to 3 teams earlier this year. A team by Blue Origin, which is Jeff Bezos, the owner of Amazon. That's his company. There's a Blue Origin is a team with Lockheed Martin and Draper and Northrop Grumman, I believe. SpaceX is a second team. They're doing it on their own. And then a third team with a company called Dynetics, which has like 25 different subcontractors. So there's 3 different models of how to do it, but each of those, and it's still a competition. NASA's going to down select next year to probably 1, maybe 2, but probably just 1 provider to develop a human lander system to be ready to go to the moon by the end of 2024. And this, again, like I said, this would be a service. Whoever is picked, Blue Origin, SpaceX, Dynetics, they would own and operate that vehicle, and NASA would basically just purchase the service from them. I tell people instead of buying a car, it's like either renting a car or calling a taxi. So that's what that's like. And Human Lander is a new program to do that, but NASA's done this previously. Excuse me. There we go. Oh, there we go. Well, Commercial Crew Program. Actually, I think I accidentally deleted a slide there. But Commercial Crew Program is has the it's by two different companies, Boeing and SpaceX, and that was a commercial procurement. Oh no, excuse me. This is I wanted to show you the Human Lander system, the three different companies. This is SpaceX. This is actually a prototype Starship that's down in Boca Chica in South Texas. SpaceX is building a launch facility down there. They want to launch this down in Texas, and it's kind of hard to get a feel for how big this is. And they're going to stack that on top of one of their Falcon Heavy rocket, or a Falcon Super Heavy rocket. So that's going to be a huge vehicle. Dynetics, this is a drawing of their lander on the moon, their descent element. Excuse me. And then the Blue Origin team, there's the Blue Origin team with their ascent element, the descent element, and the transfer elements all tied together in orbit around the moon. So those are the three teams that are competing for the Human Lander system. There we go. Commercial Crew Program, like I mentioned, is Boeing. You got the Boeing Starliner on the left and SpaceX Crew Dragon on the right. And these are the astronauts that were chosen by NASA to fly. The one in the middle is Chris Ferguson. He's actually a Boeing employee. He was an ex NASA astronaut. He's a Boeing employee. And I just heard today he was slated to fly the first Boeing mission, but it got delayed until next year. And apparently he's got family commitments that he can't make it. So he's bowed out of the flight next year, which I know kills him, because I know he wants to be on. Everybody wants to be on the first flight. So this is a SpaceX Crew Dragon on the launch pad, and they actually are on. They took over launch pad 39A, which is where Apollo flew from to the moon. They've modified it to handle their vehicle. There's a long duration of their launch, and you can see their booster coming back down and landing in the ocean, which is their unique thing that they do. Yep. And you can see here it is coming back on the barge back to the Port Canaveral. And then here's Boeing, their Starliner, CST-100 Starliner on top of the ULA rocket, getting ready for their orbital test flight from last December that they flew as an uncrewed flight that they flew. And this is the vehicle, lands, there's lands on airbags and parachutes and landed out in the desert. So two different ways of doing it. Like I said, these vehicles will be owned and operated by Boeing and by SpaceX, and NASA will just contract with them to fly astronauts to the space station. You probably saw SpaceX had their Demo 2 launch with crew that flew back in May, I believe, Bob and Doug. And we're getting ready for the Crew 1, the first certified mission. That was a test flight. The Crew 1 mission coming up at the end of October or 1st of November will be the first of the flights that NASA has bought to take astronauts to the station. So that's exciting time. We can now, we don't have to pay a bunch of money to the Russians. We can launch whenever we want to. And that's one of the reasons why NASA wants to develop two different providers. Wants to get Boeing and make sure Boeing gets there as well. So we've got Boeing and SpaceX. So we've got two completely different ways to get there. And they may take that same kind of tact with the Human Lander system. We'll see. So what have I learned? back to the question of, how does an ag engineer wind up working in the space program? Well, you got to find out what your passion is. And I figured out that I liked engineering, like science and engineering. And then I really did enjoy the space program. And so, I decided that's what I wanted to do. And then you look around and you say, well, okay, so I'm here and I'm doing energy audits on tobacco barns, and I'm helping greenhouse growers heat their greenhouses. How's that going to get me to the space program? Well, I started thinking like, well, a greenhouse, you've got temperature control and you're controlling the environment, and that's not a whole lot different than what you've got to do in a space station or a lunar base or Mars base. Sure, the environment's a little harsher, but I'm sure the environmental controls have got to be similar. So I would focus on that and how that would apply. So whatever I tell people, whatever you're doing, if you're in a job now or you're doing something and you think it's not something that I want to do like the rest of my life, that's okay. If there's somewhere else you want to go, you're probably doing something today that's going to help you get where you want to go. So instead of worrying about, I'm not doing the things I want to do, look around and say, well, what am I doing right now that can help me get to where I want to go? And there's always something that you're doing, no matter where you are. There's some skill you've learned, you've picked up that will apply and help you get to where you want to be. So that starts with finding your passion and figuring out how you get there. And then another thing is network. Professional societies, alumni groups, whatever. Every job I've gotten until this job, somebody told me about it. Somebody introduced me to somebody that helped me get the job. I mean, it wasn't somebody got, hey, my buddy gave me a job. I'm not talking about that. I'm talking about, hey, who works at Lockheed Martin? Who do I know that works at Lockheed Martin? Oh, well, hey, this person went to Georgia and we kind of went to school. What did I do? There we go. We might've been at Georgia at the same time, and he's working there or she's working there. I'm going to talk to her and see if she can advise me and help me figure out if there's any openings there or what this job, I'm going to apply to this job opening. I wonder if this person can tell me exactly what it means and, look at my resume and make sure I've tailored it correctly. So, it's a lot easier today with things like LinkedIn. I was talking before the meeting. I've had several students contact me through LinkedIn asking for advice or questions or whatever, and I'm always happy to do that. And I've done the same for other things. I've asked the same types of questions of other people, and that's the point of things like LinkedIn, and that's the point of societies like AIAA or the American Society of Ag Engineers or Agricultural and Biological Engineers, it is now, or professional societies like that. That's what they're for. So join these groups, find out what's going on. I never would have found out that there were ag engineers working in the space program if I hadn't gone to the Ag Engineering Society meeting. So make sure you take advantage of those. And then once you get to the job and you're at your dream job, go in early, stay late, put in the time, do things, it's enjoy it, relish it and put in the time to do the work, which kind of looks like it conflicts with my next statement, but go home at some point, go home. I really enjoy my work. I always enjoy my work, but it's not my life. There's life outside of work. So I've watched from the very beginnings of working in the space program. I've seen a lot of people come in that probably just as passionate or more than me about working in the space program. And they put in 70, 80-hour weeks and they burn out. And, in 2 or 3 years, they're sick of it and they go off to the next job. And I hate to see that, because for one, I like to see people work in the space program that are passionate about it. And, they've got a lot of talents to share, and you just hate to see somebody just burn out. So, whatever your limit is, whether it's a 40-hour week or a 60-hour week or whatever, 80-hour week, know where your limits are, and don't be afraid to go home and take a break. Also, don't be afraid to try new things. You know, I'd always worked life support systems, and then when that big Bioplex project was canceled, and they said, "Hey, there's an opening over here working with this Crew healthcare system, checks hardware." You know, my first reaction is like, I don't want to do that. I don't know anything about that. But you know, it's like, okay, I'll learn it, because I learned how to process flight hardware, and I learned the processes and things like that. It opened me up to a different world things, and so it was great. And you know, along that same line, also was, you know, when I left the space program, and I went and worked in oil and gas for a year and a half doing environmental testing. Well, also don't be afraid to admit that it doesn't work out. You know, I got there, I was like, you know, this is a nice job. It's important work. People need to do it, but it's not for me. I didn't have a passion for it. And I also found myself surrounded by people that didn't have a passion for it. And so, you know, it's like I quickly learned that I missed working in the space program. And so, you know, I went back, and I've been, you know, that was one of the best moves I made. I really enjoy coming back, you know, going and leaving the space program. I hated it at the time. Well, after a while, I hated it, but it really made me appreciate working in the space program. So I was glad to come back. And then the last one is, you know, same thing you learn in kindergarten. You remember the golden rule. Um, in particular, aerospace is a small world, and it's amazing how often you come back to working with people that you used to work with. So treat people the way you want to be treated. Don't burn bridges. You know, don't get mad. Yeah, everybody gets frustrated, but you know, treat people the right way. And when you inevitably cross paths with those people again in 10 years or 20 years, then it's a pleasant thing. You know, I just started working on the human landing system, and there's probably a half dozen people that I worked with that are on this program that I worked with 25 years ago that I hadn't seen since. And it's, you know, kind of like old home week. Oh, hey, Bill Wells, I can't believe you're, hey, Christy, how are you doing? Hey, Chris, you know, so it's, it's refreshing to see those people. And it's also, you know, nice to think back and, you know, remember that I didn't really get frustrated and yell at Bill like I wanted to 30 years ago because, you know, now we're working together again. So just keep that in mind. And with that, I think that's all I have. I'll open it up to questions if there's any time. I know I rambled on a little bit.
Hi, Russ. I know you talked a lot about certain qualities you thought would be great. I didn't know if you had one in particular you thought that would be the most desirable in the aerospace field.
You know, to me, I think it's decide what you want to do and be passionate about it, and just let that passion show. You know, I can't point to one technical skill because there's so much to do in aerospace. I mean, look at me. I'm an agricultural engineer. I wound up working in the space program. So y'all are already ahead, you know, all of you are already ahead of me because you're mechanical engineers, chemical engineers, biological, you know, you're already in a field that most people recognize, and it's in aerospace. So I can't highlight any one particular skill. You know, whatever you enjoy. If you enjoy mechanical systems, then focus on that and be passionate about it. If you enjoy, you know, computers, you know, flight, you know, look at flight software. If you enjoy biology, then, you know, look, or, you know, exercise physiology, for example. I mean, you know, there's a whole groups of people that look at the health of the astronauts. I mean, so there's not one technical skill I can point to, but I would say whatever it is that you are good at or that you enjoy. Well, first I'd say what you enjoy, and then hopefully you're good at it. If you enjoy it, you're probably good at it. Focus on that, and then find out where that's used in aerospace, and then that's or wherever you want to go, find out how that's used and make that your ticket.
Thank you.
Jumping off of Ryan's question, so you kind of talked a little bit earlier about transitioning like to NASA from Warner Robins Air Force Base. How well did you feel prepared for the the controlled ecological life support system? I mean, it seems super heavily involved, and so did it kind of seem overwhelming to you, or and how might we as students kind of go about preparing ourselves for a potential career at NASA?
I'm sure I was overwhelmed. Well, I was excited. I'd pursued that job for 2 years. So when I got that, man, I was so excited, and they could have told me to go out and shovel out the dumpster and I'd have been happy to do it, but that, I had to learn, but that's expected. And one thing, you're not going to go into aerospace and all of a sudden you're designing the docking mechanism for the next spacecraft. That's nobody's going to expect you to do that. They'll want you to understand the mechanical principles behind how that works. And maybe if you graduated, maybe you're coming out with a master's and you did some research or you had an internship on some mechanisms or things like that, then they might expect you to understand some certain concepts and things. But people expect you to learn. And when I hire somebody and I have somebody new coming in, all I want them to do is have a good attitude and to apply good engineering judgment and principles and ask questions and go to it. I'd say probably don't be afraid to ask questions. I would much rather have somebody ask a question or say, hey, I'm not sure I understand this, and have me have to sit down and explain it than to come back with something totally wrong or that makes something worse, or that's not what we asked for and we just wasted the government's time or money. So, don't be afraid to ask questions. No matter what your job is, you're probably going to feel a little overwhelmed sometimes. Even now, when I go to a new position, like when I left and went to the human lander system, I didn't know anything about what the human lander stuff was yet. So I had to go and read up and look at the different concepts and different things and the requirements documents and, what are they planning to do? And, you see certain things and, so I'll see certain stuff and I may have seen it in the past. But I've got, friends, I'll talk to one guy that's a genius and I'll say, hey, John, tell me again how this, this amine bed system works. And he'll say, oh yeah, here's a pitch here, look through this, or he'll just call me up and say, oh yeah, it does X, Y, and Z. Okay, great. So, asking questions and just being afraid, not afraid to ask questions and be ready to learn. That's the biggest thing. Don't let it overwhelm you, because coming out of the program you're coming out of, you'll be well prepared, but you're not going to know all the answers. So,
yeah. Thank you.
I actually had a very similar question to that, believe it or not. So you told us you started out working on an Apple II, and then you ended up working on NASA grade projects per se, and you mentioned that you had to work to understand that. I guess a little thing I was curious about is, did you ever have like any mentors or anybody who could help guide you through the process, or was it kind of all a solo learning type thing?
I did. When I came through, there wasn't a formal mentorship program that I knew of, but I was lucky enough to work with a lot of older engineers that were just great, fountains of knowledge, just really brilliant men. And I'll say men because back then they were all men. I've since worked, now I work with a lot of brilliant women as well, and I'm glad. But when I first started out, especially just got to NASA, there were two agricultural engineers. They were the only two agricultural engineers within NASA anywhere. They were both at the Kennedy Space Center. And so we had that common bond. We were both ag engineers. And then, John Sager was he's a brilliant man. He was a PhD and he was a great guy. And so John was the kind, he would tell me to go do something. He worked for NASA. I was a contractor. So basically I worked for him. And I'd go off and try to do it. And I would come back and, he would say, well, we're looking for this or that. Or I might go back in and ask him, and, I could just go sit down in his office and talk, and we would just shoot the breeze about, how we're going to do this thing or how we're going to solve this problem. So in that regard, yeah, I had mentors and stuff that would help me. But, at some point, some of the technology may have been, like I said, I was going from Apple IIs to programmable logic controllers to PC-based control, more sophisticated computer-based controls and things. And, that wasn't necessarily John's forte. And so, at some point you just pick up the manual and you sit down and you try to figure it out yourself. Or, if it's that was in a research environment, then as I later moved into more, flight environments with NASA, then it's a lot more structured, and then you've got manuals and things and people that you can ask that understand. There's more corporate knowledge you can go and ask. In the research, if you find yourself in the research environment, though, at some point you have to sit down and figure it out, and that's fun, right? I mean, you kind of sit down and play with things, and depending on what the expectations are. It can be a lot of fun. It can be a lot of pressure, or it can be a lot of fun, or it can be both. So.
Awesome. Thank you.
Sure.
If I can you hear me okay? I'm sorry, I'm calling from my phone.
Oh yeah, I can.
Okay, great. So I had a question about career planning, and to give a little bit of background, I'm currently a co-op with Gulfstream Aerospace, and I don't know if you know anyone who's working over there, but they went through reductions in force in the last year, and a lot of people would say things like, well, if you work for someone like NASA or someone like Lockheed, they're government contracts, so the aerospace industry isn't as cyclical. And I was just wondering, you've transitioned back and forth, from NASA to some of the more private sector. What has that been like for you? And would you say that it's also still sort of cyclical, even when you're working under contracts, or not?
It's different. And I think it's probably a little more stable, but as I tell people, you're working under the whims of 535 of our finest up in Washington, right? So you know what that can mean sometimes. Like, sometimes they decide that, well, they don't want to fund the government. And, so everybody goes home for a month or so until they decide to pay people. Or they decide that, it's we don't like this project anymore. We're going to cancel it, and we'll get around to funding the next project, next year. So, there can be gaps like that, but I've been pretty lucky. You kind of you can't worry about those types of things if you're working on the government contracts, because, the only control you have over you really have over it is every November, the voting booth. That's about it. It's probably, but it is different from industry, though. Industry is more immediate. If they need to shut down or do different things, they can do it right away. The government can certainly do that too, but they typically don't. So it's they both have their pluses and minuses. I'm used to the government world just because I've worked in it for a while, and so I've kind of gotten used to any of the vagaries that kind of come along with that. I haven't been in a commercial industry that wasn't that was just completely divorced from government work at all. And, like Gulfstream, I imagine is, probably not dependent on government much at all. And so, that's tied to completely different cycles, and that can be more cyclical. I see it here in oil and gas because, like I said, oil and gas is huge here in Houston, and we'll have engineers that oil and gas is booming, and they'll leave because they go get a 50% raise, and then 2 years later, it's like, oh, hey, Chris, hadn't seen you. Yeah, they lay it off everybody. They get, so it's boom or bust in that. I think oil and gas is a little worse than other industries, but it's, unfortunately, that's just kind of the way the economy is these days. When I was coming out of college, it was, the thought was you got a job and you went and worked for a company, and then you retired from that company 40 years later with a pension. And it was like, nah, it's not like that anymore. So you always need to keep your skills polished, be aware of what's out there. I still get job notices. I love my job. I'm not looking to change jobs, but I still subscribe to job notices from different companies and things. So I get the notices of what's out there, because you never know what's going to happen. So that's probably the one biggest thing is, one, don't worry about it. And two, just make sure you've got a good resume prepared. And like I mentioned before, whatever you're doing now, if this job goes away and you've got to go to the next job, or you want to go to the next job, make sure you understand what you can take from this job to that next job, and what you can take from that past job to the next job, because you've got skills. You just make sure you can express them to other people.
Okay, thank you so much. I really appreciate it.
Sure.
I'll ask another quick one. Just talking about the Orion and the different commercial or traditional NASA procurements. So we have the human landing system, which is going to go to the surface. Is the Orion then not going to go to the surface? Is it just kind of going from like Earth to the gateway? And
yes,
okay,
yeah. Orion goes from Earth to the gateway, and then they will transition to the lander that will goes from the gateway down to the surface of the moon.
Okay.
So I think that's just partly because Orion's not designed to land, like that.
Yeah.
It's just a different technology. It's just like in Apollo, you had that LEM, that weird spacecraft. So that's why the pictures of these different landers look so different. Now, SpaceX is kind of doing it the science fiction way, the giant rocket that goes and lands and sits down on the moon. But Blue Origin and Dynetics are doing it the non-aerodynamic lander that will go to space, go to the gateway, and then from there it'll go down to the moon.
So then with the commercial, like the Boeing Starliner and SpaceX's Crew Dragon, how is that then like different from the Orion? I mean, because that's also a way to get from Earth to the gateway, right?
No, those are only meant to go to the space station.
Okay, gotcha.
And so, the main difference there is just capability. Orion Orion, has life support systems and that can last up to 21 days. So they use some recycling technologies and some they can't take a bunch of supplies with them, so they have to recycle and reuse a lot of resources and things. And it's not actually made to dock to station, although I think it could now. I don't know. Anyway, I don't work docking systems, so I'm not. But it's so they've got different capabilities to where the Crew Dragon or the Starliner, they're designed to have a mission for 2 or 3 days at most. And that's for contingencies. Basically they launch and go straight to station, and so if for whatever reason they couldn't dock the first time, then you stay up a day or so, or you undocked and you had to stay a day or two. So, it's 2 or 3 days for contingencies. It's really designed to go straight there and come straight back. So it's a taxi ride or a rental car.
Yeah.
So
Gotcha.
I'm just cycling through pictures of stuff that I think looks cool. So
Yeah, feel free. Anybody else that has a question, go ahead and.
Yeah, I have a quick question. So kind of along the lines of what Selena asked, how would you compare working at NASA under the government and working in private aerospace, both in terms of the work environment and also the actual work you were doing?
you know, so I'm working in the traditional government contract world right now, and I've done that for most of my life. But I really enjoyed working commercial aerospace, and I'm really excited to see that blossoming. I mean, stuff that SpaceX and Blue Origin and those folks are doing, Virgin Galactic. I mean, that's fascinating. I loved working at Paragon. Bigelow was exciting. It was a little challenging from the work environment personnel kind of standpoint, but it's, you're dealing with, when you get to things like that, you're dealing with billionaire egos and stuff, and that can be interesting. Working commercial crew, I worked commercial crew for about 4 or 5 years from the government side, not with on the commercial side, but I got, a good insight to watching SpaceX work. And it's amazing what they can accomplish. And I would never bet against them. I mean, looking at what they can do, yeah, they make mistakes. They do some things, that that NASA probably wouldn't do, but they accomplish a lot of stuff that NASA probably wouldn't accomplish in 10 years.